Looks like we're having a couple of issues. Ah, yeah, I think you can grab a drink now. Um, I'm keeping an eye on Stephan. And he's back. Let's hope it works. I hear you loud and clear, Stephan.
So somehow my wireless microphone fucked up. Oh, am I allowed to say fucked up? I don't know.
Yeah, we will bleep it.
Yeah, thanks. Let me quickly find my screen. So,
You should have all the things now.
yes, so you should see my screen, right?
I see your screen. I
Perfect.
see it going black a little. Now I see
Yes.
it moving.
Awesome. So just moving the presenter thing around. So I just need to figure out to not step over the cable, but that will work. So starting over again. Hi, welcome everybody. Welcome to this talk again. Hopefully things are working now. What I said is thank you, Michelangelo, for inviting me to speak at this meetup. I know usually January is PHP Benelux conference time, and guess some of you may have seen me once or twice, and maybe have seen me speak a bit more times as well. So I'm really glad to be here. When Michelangelo asked me to do a talk, I told him that I just have one talk in my repertoire, and that's actually the talk I gave at PHP Benelux conference last year. But since it's pandemic, I guess you all have forgot about it, and I can just restart it, and you will not notice. So the question for this evening is, how good are my tests? And that's a pretty damn good question, I guess. Let's see if we can answer this throughout of the talk. If you don't know me, hi, I'm Stephan. Um, if I'm not speaking on the small stage right now, I usually love to speak at all the big stages. I had my shows running in Las Vegas on the Broadway. I played in football stadiums, in theme parks. But I do actually love the community conferences and community meetups. Sadly, as a speaker in the PHP world, I can't finance my living out of that, so I need a little side hustle, and that is my company, BitExpert, which technically I'm running daytime right on the screen behind of you, or something just on the other side of the table. If I don't do that, I still have some spare time left, and I do not run one, but actually two PHP meetups. One is the PHP Meetup Frankfurt, and the other one is called PHP Meetup Metropolregion Rhein-Neckar. I know that is a very German name. If you do like meetups, the Frankfurt meetup will air next Thursday. It's an online meetup as well. We do have two amazing talks. Niels Ademann will tell us all about Composer version 2. So that's definitely a talk you should not miss. And we'll have Daniel and David talking about public-private key encryption in the browser, in the PHP backend, and how to make things work back and forth. So that should be also quite interesting. That's enough of the marketing buzz. Let's get started with a talk. Before we focus on how good are your tests, we probably should first focus on the question, how good is your code, right? Because that's where everything is starting. Now, there are a couple of tools online that you can find that give you some idea how good or bad your code is. Things like this, there's Scrutinizer, there's Code Climate, there's SonarQube, there are a bunch of tools out there. What they have in common is that they do analyze your code, and in the end, they will present you with a number or a rating. Like in this case, 9.46. And written below, it says very good. So that should be quite decent code base, right? Downside is I don't really know what's going on under the hood and how this result was calculated. So I'm not really sure how good my code base really is. And if that's a 9.46, like what's the upper limit? Is it like a 10 or maybe like 20 or something? I don't really know. So maybe we should figure out a way of identifying what good code means or what good code is. Now, if you hop on Google and Bing for code quality, you probably end up finding an ISO standard. So there's not an ISO standard for code quality particular, but an ISO standard for software quality. Now, if you heard the term ISO standard, you probably better run fast, right? We really don't want to deal with these standards. But what's it made of? Like, what's the criteria they are talking about? Well, first, they're talking about functionality. They are talking about reliability. They are talking about usability, efficiency, maintainability, portability, like all these ability words, these big words, right? But to be honest, I don't really know what that means. I mean, if I look at my software, yes, it works. So I guess it's functioning. It looks like it's reliable, usable. Well, I can use it, so that's cool for me. I mean, I'm a developer, so I might have a special view on that. Efficiency, well, I guess it's okay. Maintainability, sure, I can make changes. Portability, yeah, maybe. So that's not really something that really helps me identifying code quality. So if you hop on Bing and Google for what is the good criteria for good code, you'll come around like hundreds of blog posts all around the world. I didn't read them all. I just read like one or two, and I figured out there's a common sense of criteria for good code. And the first one that I identified is the question, how good can I follow along? How readable is the code, and how easily can I understand what the author tried to say with the code? The second criteria is it at least possible to somehow in an automated fashion test the code, unit tests, end-to-end tests, whatever. And then how easy is it to extend or modify the code without breaking it? And this kind of helps, I guess, to start coding. So let's start coding, and obviously let's start writing tests. And I know it's a bit late, so I'll throw in a motivational yeah at this point, just to get your attention back, maybe. So we have the code, we have our tests, and then naturally the next question is, how good are the tests I've written? And usually when I'm at conferences and I can get feedback, instant feedback, people in the audience will throw a word at me, code coverage, right? That's like the metric for testing. So let's have a look if that makes sense. So this is the code coverage graph for this project I'm playing around. It has a code coverage function and methods coverage of 98.57% and a class and traits coverage of 96.97%. So that I would say that that's pretty well tested. Yeah, okay, so that has to be a good code base. That has to be a good test base. But is code coverage really the right metric for test quality? And obviously, by phrasing this question that way, you can probably guess the answer, and I'll just try to prove it to you. So let's take this test case, for example. Default value defaults to null. We do instantiate a parameter class. We pass in a configuration array. And then we call the get default value method, and we'll check if the default value is null when we have not defined it in the configuration array. Cool. So let's say this gives us 100% of code coverage. Great. So one of your fellow developers comes along, makes a few modifications in code, and accidentally deletes the assertion. Now, thing is, you still get 100% of code coverage out of this, but the most important thing in the test case, the assertion, is not there anymore. So the test is completely useless. And this clearly shows that code coverage is not the best metric to measure test quality. I'm not saying code coverage is a bad metric at all. It definitely gives you some insights in how well your code base is tested, but it doesn't tell you anything in regards how good actually your tests are. So what are good tests? Again, if you hop on Google and Google for it, you'll probably find the principles of unit testing. So there's an acronym, it's called FIRST. The F stands for fast, so unit tests need to be executed fast. The I stands for isolated, so a test shouldn't have any side effects at all. The R stands for repeatable, so the results should be repeatable. You always get the same results if you run the same tests over and over again. The S stands for self-validating, so the test should describe pretty much what it's doing and why it's doing things. So kind of like documentation part, you could say. And the T stands for timely, meaning you should write the tests either before you code, if you do if you go by the TDD way, or just right after you just created the code, but not like 6 months later or a year later or whatever, because that just doesn't make any sense. Why is that? Because you may not remember which implicit assumptions you have taken when you have written the code. And I guess this is a very important question to this whole topic, because obviously when we write code, we make assumptions, and with assumptions I mean things like how to structure the code, like what's the order of the different if statements, where do we have nested if else statements or whatever. These might not be part of the specification that you get when you write the code, but just like your assumptions, your way of doing things. And if you don't remember why you did that, it's then really hard to write the right tests for that. Okay, so we have our tests, but like how do we know now if the tests are good or bad? Well, we have code and we write tests for the code to figure out if the code is right. So if we have tests and we want to verify the tests, obviously we have to write tests that test our tests. And if we have tests that test our tests, we do need tests that test the test of our tests. And if we have tests that test the test of our tests, we need tests. Well, you know how this is going, right? I don't want to go on forever with this. Just move back for a second. Back to the basic questions, like how would we test such a test? Now, if you have a look at this code example I showed you earlier, what would we need to test? Well, first of all, we need to test that the parameter class gets instantiated. We would need to test that the right configuration array would be passed in. We would need to test that get default value is called. We would need to test that the assertion, the null assertion is called. So basically, we would duplicate this logic into some meta language or whatever, which is completely pointless, right? I just duplicate this part in another part. So that does not make sense at all. So we need to think differently. We need another way to make sure or to figure out if the test is working or not. Now, there's actually a pretty easy way of figuring out if your test is working or not. Why not change our code and see how the test reacts? I mean, not like change your code, but like break your code. Like we do something we do on a daily basis, right? We do make some changes, run the tests, and boom, everything is red. So basically, we are simulating real life. And that is the whole mystery, so to speak, behind mutation-based testing. As with all the cool stuff in IT, mutation-based testing came to life in the last century. And saying that makes me really feel old. It was born in the 1970s, if I remember correctly, and is based on two theorems. One is called the competent programmer hypothesis. And I know you all think right now of this one colleague that definitely does not seem to be competent, right? I got you. But the gist of this is that basically we all programmers are competent. If we get a specification, let's say a customer comes to us and says, hey, let's build me a CRM system. You would never end up giving the customer an inventory management system or an HR tool or maybe a content management system, right? You would build him or her any kind of CRM. It might not fit the requirements in detail, but like in general, in a whole, you definitely build something that you could say is a CRM system. The other part it is based on, or the other theorem is based on, is called the coupling effect. The idea behind of this is to say that we are dealing with simple errors and we are dealing with more complex errors. And every simple error is causing a complex error, is the cause of a complex error, meaning we don't really need to care about the complex errors. Just to rephrase this a bit to make it a bit more understandable, that means if we need a tool that does this mutation testing thing, it does not need to understand what a method is doing, right? We don't need any complex AI, machine learning, new hot stuff that would figure out like, oh, this method is doing X and I need to change this and that to make it break. That is completely irrelevant. What we can do is we can take out simple parts and just change it, and this will surely break the method we are testing. And that then should make the test break as well in an ideal world. That is this part of this theory. So these little changes are called mutants. So again, you take, oh, sorry, this is like, we are in a PHP meetup, right? So these are the wrong mutants. I just meant these are our mutants, right? That's a lot better. So each of these mutants is a small incremental change of the existing source code. That means this mutation-based testing framework will take your source code, it will find, let's say, a plus sign and change it to a minus, and then run the tests and see what will happen. Now, these mutants are generated by so-called mutators. Depending on your mutation-based testing framework, there are a lot of those. So this is just like a small extract. There are mutators that change the function signature, turning public functions to protected ones to private ones, binary arithmetic mutators, Boolean substitution mutators. We'll see that in a second. Changing looping, changing sorting, changing typecasting, throwing random exceptions, having fun with some regex expressions and whatnot. Let's have a look at least how one of them works, the Boolean substitution mutator. So as I said, it will go through all of your code. It will figure out, hey, there is a true statement in the code. We'll change it to false. Hey, there is a false statement. We'll change it to true. There's a logical and, we'll change it to a logical or. There's a logical or, we'll change it to a logical and then for the logical lower and logical lower or as well for logical not, which is probably changed to not. I don't know. Let's have a look what does that look like in practice. So this is the constructor of this parameter class I showed you before. The most important part is this if not is name on the very lower part of the screen. So we'll try to extract the name of this parameter out of the configuration array, and if it's not set, we'll throw an annotation exception. Perfect. Now, when this mutation testing framework figures this code out, it will change the if not this name to an if this name. Meaning that our tests that expect an annotation, the annotation exception to be thrown, will hopefully fail because it doesn't happen. And other tests that don't expect the annotation exception to be thrown will actually get it thrown, and the test will fail there as well. If you have tests where none of that happens, you know that these tests are not designed in a good way. That's the whole theory and the whole idea of mutation-based testing. Super simple, but it took me like, I don't know, 3 or 4 times to figure out like why the heck this thing is changing my source code and complaining about stuff. We'll see that later, what this thing complains about. So each of these changed source code variants is called a mutant, and such a mutant can have different states. A mutant can be killed, means the mutation was properly detected, so tests failed. A mutant can be escaped, which means the mutation was not properly detected, so the tests are green even if they shouldn't be. There is the state that is called uncovered, which basically means there is no tests for this mutation, which may or may not be a problem. We do have a fatal error state where the mutation-based testing framework made a code change and it just blew up the PHP engine because it just did some crazy stuff that was completely unexpected. And you got timed out mutants where the mutation-based testing framework just does not get any feedback at all from the test suite you're running. So there's actually just one mutation-based testing framework in PHP at this point, at least for PHP 7. It's called Infection PHP. There used to be an alternative, which was called Humbug, which was solely focused on PHP 5, and then they never made the jump to PHP 7 and the abstract syntax tree. So Infection PHP kind of took over and is currently like the de facto standard, I would say. The pretty interesting thing about Infection PHP is that it does support a variety of testing frameworks. So it's not bound to just PHP unit. It can support others as well, which makes it really interesting in real life. So it does support PHP unit out of the box. It does support PHP spec out of the box. And it also supports Codeception out of the box. The cool thing is that Infection PHP does not hook into these different testing frameworks. It just analyzes the log output, meaning it's kind of independent of the different PHP unit versions or PHP spec versions, unless obviously they completely change the way the log files are written. So that makes it really flexible, and that's pretty cool. So how does Infection PHP work internally? First, it will run the test suite to see if all the tests pass. If you got failures, it does not make any sense to run it further. It will mutate your source code with a set of the predefined mutators. It will run all the tests that affect each mutant. So it doesn't run like the whole test suite if you just changed one line and it figures out like this one line just belongs to these couple of tests, just to speed things up, obviously. And then in the end, it just collects all the results of all the killed, the escaped mutants, the errored ones, the timeout ones, and then presents you with the results. Now, it's quite easy to install Infection PHP. You just need to grab it from GitHub. Either go on their GitHub page, download it directly, or use a service like Get Latest Assets to just grab the latest version. If you have it, you just run it. And on the first run, it will figure out, hey, there is no configuration file around, and it will ask you a bunch of questions, like what's the source directory, anything you want to exclude, where is your PHP unit configuration, which timeout should be used for the test suite, where do you should we store the log information. That's really important in the at a later stage when you want to debug things. And then this file gets created. It's just a JSON file. You can edit it later on. I'll show you what you can edit in a few seconds. That's basically it. So if you run it, just run it again with the same command, PHP, and then pass the FAR file into. This is the output you'll get. You'll notice the first couple of lines, that's just the PHP unit test suite that is running. And then it's generating all the mutants. And then for each mutation, you'll see a PHP unit-ish log output. They can get a good overview of all the killed, the escaped, the uncovered mutants, the fatal errored ones, also the timeout ones. And last but not least, you get a bit of statistic, what was going on. Like in this case, we generated 325 mutations, out of which 255 have been killed. One mutant was not covered by a test. We'll see that later, how we can fix that. 60 have been covered, but were not detected. Nine errors were encountered, and so on and so forth. And then you'll see the metrics down below, which I'll cover in a minute as well. As I said, Infection PHP, you will write a log file, and this is very important because otherwise you have no idea what's going on, what it did, how to fix the not covered mutants or the covered but not detected ones. Without that, you would just like speechless here and say, okay, this is like crap, I'll just move on, which is more or less what happened when I tried it the first couple of times. The log file will give you information about the escape mutants, about the timeout mutants, and the not covered mutants. It will exactly show you what's like the original line of source code and what change was applied, so that you can easily figure out what's going on. Like in this case, this was one of the escape mutants. So in this get function, I had to check that if the ID that is passed in is not a string or empty, then an exception would be thrown. And Infection PHP changed this to if the ID is not a string and is empty, then the exception gets thrown. In that case, I didn't catch in my test cases. It took me a while to figure out, like, what do I need to pass in that would match this? Like, what is not a string but can be empty? If you have any idea, just post it in the chat. I'll be curious to find out if you have an idea. Exactly. Nah, 0 is not the right thing. It's an array. An array is not a string, but it can be empty. So what I did is I just added a test case. I just passed in an array and just listen for the, or just figure out if the exception is thrown or not. And then that made this escape mutant go away. Win. Moving on. This is also nice. So in this case, we'll get a value from somewhere. We'll string to lower it, and then we'll compare it to true. So we are basically parsing something, and we'll figure out if this is true or false in a Boolean fashion. Now, what infection PHP did in this case is it just removed the string to lower call. Damn it, test failed. So how can we fix that? Well, easy. We do not only pass in the uppercase values of true and false, we just also run the tests for the lowercase versions. Win. Now you could ask yourself, does this really make sense to test it? And you can, I mean, this is really hard to say. Just move back a bit. Technically, even you could make that mistake. Let's call it that way, right? You navigate through source code, and then by accident you just delete this line. So obviously, it makes sense to have some kind of validation in there. It also gives an opportunity to rethink your logic. Like, does the string to lower in this case, in this place, really make sense? Maybe we should move it to a different way. Maybe we should move it to like the parsing section, so that we always know true or false will be passed in here as lowercase letters. There's like no variation at all going on. So see this as a kind of opportunity to rethink how you have structured your code, just to get a few more ideas. So what else do we have? Another escape mutant. So what happens here is I do generate a bunch of PHP code. To be a nice person, I thought, well, let's add a doc block comment, just add inherit doc, just to be nice. Infection PHP just removed that line, and the test failed. Meaning I didn't really check in my tests if the doc block was set or not, and how it was set. Technically, I don't give a damn. So what I did is I completely ignored this error, because it does not make sense to test this, because it doesn't have any effect on the generated code. So I just ignore that. Technically, I could have written another test that would just test if the generated doc block would contain the add inherit doc marker. So that also shows you that you can definitely decide what makes sense to fix and what not. It probably doesn't make sense to fix each and everything infection PHP finds. So it's really like going back and forth, figuring out like what makes the most sense or not. And if you remember, there was like one not covered mutant in the statistics, and it was this one. And this is also brilliant case. So what's happening over here is we loop over a couple of aliases, and an alias could be either a string that is defined by a user, or the type of the object that we are referring to. So alias can actually never be empty. I, being the old programmer I am, I just added an if empty alias condition there, and just continue then with the next one in case this would ever happen, right? Defensive programming. Now, infection PHP came along and said, okay, there's a continua there. Let's just replace it with a break and see what happens. And obviously that was not detected at all, because I can't really test it. It does not make sense. So the fix in this case was super simple. I just got rid of the if statement. It's pointless, right? The $alias, it can never be empty. It's completely useless that this is in there. So infection PHP also gives the opportunity to get rid of your code, at least in some parts. So having fixed all of that, we are down to 324 mutations that have been generated, and the one was the not covered one that is now covered because it's gone. The code that is responsible for it is gone. And we've killed some more mutants. So win. Cool. Now you can see a bunch of metrics down there. I'll just quickly touch what they mean. So first we have the mutation score indicator, MSI, which is kind of like the primary metric, you could say. So this tells you how many of the generated mutants have been detected properly. Now, if the difference to the code coverage is too big, then you have an indication that your tests are not effective enough. Then we have the mutation code coverage, MCC, which basically should be in the same range as your code coverage as well. And last not least, there is the covered code MSI. So the MSI, the mutation score indicator, just for the covered code. And also in this case, basically it means this should be quite close to your code coverage. If the difference is too big, then you know that your code base is not, or your test base, I'm sorry, is not effective enough. You should really work on that. So going back to our statistics, 81% mutation score indicator and covered code MSI, and 96 to 98% code coverage. That is kind of a difference, which might be okay-ish, but I guess we should work on that to raise the MSI a bit, to make sure that the test base is a bit more reliable than it really is. Seeing that like 58 covered mutants have not been detected, that really tells you something. Cool. So what I didn't tell you in the beginning is that infection PHP, as I said, was invented in the 1970s, but it never took off back then. It took off, I would say, like 5 or 6 years ago or something, mostly because of one reason, obviously, and that's performance. If I run all my tests for this project, so 134 tests, they run in under 1 second. If I run infection PHP on the very same code base with the very same tests, it will take 38 seconds. So you can see there's kind of a difference there. And obviously in the 1970s, 80s, and something, we didn't have these powerful computers that this would probably be possible. These days, we just rent some other person's computer, aka the cloud, and just run that stuff, and we don't really care. Luckily, there are a couple of ways you can do to increase performance or to tune performance. So one thing you can do is enable threading. So obviously, if you don't pass this threads parameter, the thread count is 1, which probably isn't the best. So just pass in the threads you want to run, or the amount of threads you want to run, and this really decreases the time that this thing takes. So thread count of 4, and it's like half of the time. So that's quite decent. What you also can do is infection PHP supports what they call profiles. This is this add default configuration that you can see in the JSON configuration, which will just limit the kind of mutations or mutators used to generate the mutations. So if you know, for example, that you don't care about any Boolean mutations or any operator mutations, you can set this to false, and then these mutations will not be generated. So that can speed up things as well. So I can globally disable that. You could also locally disable those. You could, for example, say the logical not mutator should not run for the class proxy configuration generator, and for any class in the proxy configuration property generator namespace. So if you run into a lot of problems there, you can add those ignore lines. What you could also say is, or limit this to method calls or method definitions. You could say the logical not mutator should not run for the generate method of the configuration generator class, or for any generate method in the proxy configuration namespace. So there's a lot of ways that you can define these configurations. What you can also do, and this was added like 2 or 3 releases back, is you can define a global source code regex pattern, meaning that I don't want infection PHP to modify any of my logger calls, right? It's just freaking login, right? I'm logging strings. I don't care if you pass in a Boolean or whatever, or an array, or maybe, I don't know, throw an exception or whatever. So that's pointless. Infection PHP also should not run on any assertion calls, because that's also pointless, right? I have these assertions in place to make sure we have guards that check stuff like I'm passing a numeric value, or I need a Boolean or whatever. So it's pointless to pass in then a string or an object or whatever. That's just generating mutants that necessarily don't need to be generated. So that's pretty decent, pretty awesome. And this is like the golden hammer method, I would say. What you could also do is you could say ignore certain mutators for specific lines of code. Like in this case, for code in line 123 in the configuration generator, don't run the logical not mutator. Now, I would try to avoid this as much as you can, because obviously if you make any changes in this code configuration generator class, you would need to adopt the line count here, otherwise things will blow up. So this is like really the last thing I would touch ever if something was failing. I would try to avoid that as much as I can. The cool thing that Infection PHP added a long time ago is that they will check the JSON configuration for the syntax. Meaning if you have a syntax error, like in this case, the E is missing for ignore, Infection PHP will throw an error at you. Previously, it would just use it, it would not work, and you had no idea why not. So today you at least get an idea of what's going on, or what's going wrong, so to speak. Now, to increase performance, especially generating the code coverage report, there's different how-tos on the Infection PHP site. You could like add the Xdebug information out of PHP unit before you run Infection PHP. Take that and generate the code coverage information, and then feed that in Infection PHP, which then makes use of that, so it does not constantly analyze the existing code base. So that should speed things up a bit. Instead of Xdebug, you could also use the pcuf extension from Joe Watkins, which is supposed to be faster and use less RAM. I don't know how that compares to the latest version of Xdebug, version 3. Just test it, what makes the most sense for you. You can run Infection PHP and CI, obviously, so you can pass the minimum values that it should check against as configuration options, like in this case min MSI and min covered MSI, and then if the generated MSI or the calculated MSI and covered MSI factor is below that, it will just fail, and then your pipeline will fail. So that's also nice. Last thing to speed things up drastically is to let Infection PHP run only on the changed files. So if you have a Git hook or your build pipeline up and running, you can like figure out like which files have been changed in this commit I'm running it against, and just feed those in via the filter parameter. And this will also speed up things quite a lot, because like, I don't know, out of like 10,000 files, you change like 5 or something, and then just these 5 files will be modified and the rest will be left as is. So that was basically it. That's my introduction of infection PHP and mutation-based testing for you. If you have any questions, let me know. I'm happy here to at least try to answer all of them for you. Thank you very much for listening.
Well, Stephan, thank you very much. Well, there were a couple of questions. Let me
move the chat over
to the QA section. You mentioned the memory thing earlier, but here is a special case where the memory, let me just say it. Have you had problems with memory usage during mutation testing? In my experience, it can quickly become a memory hogger due to the many mutations, and in our case, kills the Jenkins instance. GS example using Striker, but still mutation testing 99%, elapsed 4 hours, 11 minutes remaining. But have you ever experienced these kind of excessive memory usages? And what was your solution to that?
Luckily, not yet, mostly because we are running it on a very small code base currently. So yeah, it doesn't generate all these or that many mutations. So so we haven't had issues like that before. I mean, what could help in this case is this git changed files hack that I showed you just on the last slide. So we'll just generate the mutations for the changed files for the specific commit. If you want to run it then on your whole code base, well, get more RAM. That's probably rent Azure AWS or Google Cloud system for a couple of minutes or whatever.
Okay. Well, Mark asked the question: is it possible to use parallelization with infection PHP? But the moment he asked this question, you already showed about it. It was perfectly on cue. Do you also run it in parallelization in terms of, hey, I have multiple services? You talk about small code bases. Do you run infection PHP in parallel and then combine the results to have like a global overview, or are you going to look at it project by project?
Currently, it's project by project, and the project itself is relatively small, I would say. So we just run it in one go. I remember I did the same talk 3 or 4 months ago for the Typo 3 user group in Frankfurt. And there was one guy who said that he tries to run different instances of infection PHP, but what's not possible for him is to combine the results. So I haven't tried it. I don't know if that is maybe fixed already. It looks that that guy was already in contact with the authors of infection PHP, and I think they said that they don't think it's possible right now, but that's just pure speculation. We are recording this talk, right? So
yes,
maybe delete the last section because I have no idea.
No worries. I mean, this is a meetup. I mean,
sure,
we like to share and we want to learn. Next question by Jerome. Will infection PHP also change typed arguments or return types on functions and methods?
Ooh, that's a good one. Probably with the latest versions. Change type arguments, return types. Well, return types, I would say. Typed arguments probably, but I don't know if that was added in the last 2 or 3 releases. Do you know that, Michelangelo? Maybe.
I haven't had a look at the latest releases. The version I'm still running is not doing this. What it does do effectively is changing cast types. So when you did casting to string, that was something that infection changed. So it converts it now to integer or removes the casting entirely. So
I think I've seen it change the return types, but I might be wrong.
Yeah, we need to have a look at the latest update. I mean,
they add tons of mutators all over the place, like that. It's totally crazy. Yeah. So if it's not in the works or if it's not already done, I guess they will have something out soonish, I guess.
Yeah. And then the last question: does Infection PHP allow running with PHP unit style test groups?
I don't know. We don't use test groups at all.
Well, what it means is you have a group annotation inside your group list. PHP unit does this, and Infection actually executes on top of the output of PHP unit. So if you run PHP unit on groups, the output will effectively run on these groups that you have created with PHP unit.
I think the problem is that you can't tell PHP unit to run a specific group because it's invoked by Infection PHP. I'm not sure if you can pass in parameters to Infection that then get passed to PHP.
It depends. If you set up PHP unit to execute, and before you actually use Infection, you run PHP unit and you use the group annotation inside your code base, and you say, okay, execute only on these groups. Then the output will only have the unit test for these particular methods in those groups.
Well, the question is, does it make sense to run it on a group that just checks a part of the code base but not everything? I mean, this would not result in proper metrics then.
It depends. Sometimes you have these group annotations specified specifically for A/B testing of codes, microservices management, those kind of things.
I'm not convinced. Move on.
Well, that was the
last one. Okay.
Let me see. There's only mentioning that there is also now a Discord server. Infection also has a channel on the mutation testing Discord server. So, well, looks like we're through, unless someone has a final question. Speak now or forever hold your silence.
Well, you can always ping me on Twitter, send me an email.
Yeah.
You should know how to reach me. And if you can't reach me, just wait until PHPBenelux next year, and we'll definitely see us there.
Yeah. I just pulled up your final slide so people can take a screenshot and have all your contact details. So, okay, well, Stephan, thank you very much for doing this. I really enjoyed it. To hear someone else speak about infection besides me. Great job. Thank you.
Now, which talk do you like best? Now, let's be honest.
Your talk is more
different, right?
Well, it's more like the academic. Mine was like, okay, I show you the code, I show you how it runs,
Right.
I pull you inside the excitement of building stuff with infection. You're taking it from a different approach. So it's like comparing apples and oranges.
Okay. That's the best answer you could give.
All right. Looks like it's 8:05. We have a 10-minute break. And let me quickly check if Cees-Jan is here. Yes. Okay. So we do an audio check with Cees-Jan, and then we get started again. Stephan, thank you very much for your presentation. Thank you for your enlightenment. I hope everyone now starts doing some mutation testing on their tests. Trust me, a lot of people that saw it in action and saw the benefits of it actually implemented this on their projects, and the results were amazing. They now that they are hooked onto infection, they don't want to go back. So let me get this out of the door. All right.
Yeah, I guess that's important to say. I mean, it will take a while for you to understand why it's doing the things it's doing. That's why I try to show it to you in detail in this talk. Because when I run it, like I gave it a try, like I don't know, 3 or 4 times, and like the first 2 times I was like, what the fuck is going on here? Like, why does it change my code? This doesn't make sense to me. Like how would this validate my tests? This is stupid. And then yeah, as I said, it took like 3 or 4 times until it really clicked why it's doing that and what it means. So don't be disappointed right from the start. Just let it sink a bit and keep doing it, and you will definitely benefit from that.
Yeah, one thing I do want to mention, infection PHP is part of resilience testing, just to put it in a category, which is part of chaos engineering. So if you're thinking about implementing the chaos monkey, start with infection PHP first, and then go for the bigger fish. Okay, let's have a. It's 8:08, so let's get together at 20:08, and then we continue with Cees-Jan. Okay, thank you, Stephan. Thank you very much. Enjoy the rest of the evening, and talk to you soon.
Bye-bye.
Cees-Jan, I've made you presenter, and you should have all the controls. So underneath your video screen, you should see green icons or red icons for camera, microphone, and screen share. We lost Cees-Jan, so bear with us.
Kan jij mij nu ook horen?
Ik hoor je loud en clear, Cees-Jan.
Top. Even kijken.
Like this. Crash course into async and non-blocking PHP.
Top. Even kijken. Ja, hide. Zeg maar alsjeblieft dat het ding niet blijft terugkomen.
Normaal gezien, als je begint te presenteren, dan verdwijnt dat. Dus Google Slides, hè?
Ja. Ik ben heel aan het kijken of hij inderdaad verdwijnt of dat ik hem gewoon kan verplaatsen.
Je hebt daar zo'n knopje hide naast.
Ja, nou, dat is leuk. Dan klik ik erop. Hide.
Ja.
En als ik dan al tap, dan kom ik hem weer vrolijk tegen. Dus waarschijnlijk minimize hem gewoon heel flauw.
Ja, dat is om duidelijk te maken dat je dus aan het delen bent. Dus niet altijd.
Ja, het is compleet logisch, maar het is bij hide verwacht heel gewoon op. Maar hij stopt. Oh, zo. Ja. Je kan het share er ook mee stoppen, maar dat kan ik ook in het hoofdscherm doen. Dus. Kijken. Dan ik er ook nog even bij hebben, want dan kan ik zien waar ik ben en wat eraan komt.
Ja.
10:30 zei je?
Ja, dus nog 7 minuten. Kan je nog even iets drinken halen of zo?
Nee, nog even snel even wat drinken pakken en even er helemaal klaar voor zijn.
Jij kan deze in het Engels doen?
Ja, ik heb het niet alleen met het Engels gedaan. Dus.
Okay.
Ik heb hem, even kijken, ik ben hem eerst voor Zakra PP gedaan, toen bij Dark Mira en nu hier.
Ja, super.
Ik weet niet of ik ik denk niet dat ik volledig 50 minuten ga, hij is eerder 30 à 40 minuten, afhankelijk van hoe lang de vragen zijn. En,
het is een meetup, dus...
daarom, en ik hoop dat er vragen komen. Ik heb nog niet zo heel veel vragen bij deze gehad.
Ja.
En ik heb het ook meer als een introductie genomen. Ik merk dat het onderwerp zelf vrij heftig is voor een hoop mensen. Als het een hele shift is. Dus, ja.
We zullen wel zien. Dan zeg ik, ga je eerst even iets te drinken halen en dan zien we je terug.
Ik ben om 10 vooral terug.
Oké.
Top.
Jo. I was looking at it and I saw that 2020 was not a good moment to pick, so I gave 1 minute more.
I still have regrets about adding for our 2020 vision to the Amsterdam PHP slides back in 2019. That was not a good call.
Yeah, I know. Well, it happens, and we will continue.
Yep.
Learn from the past and move to the future.
Exactly. Should be fine.
I hope everyone has their drinks. I got my thermal mug, so I'm all good.
I got water.
That's a good size mug for water.
Yeah, and it saves me trips downstairs during the working day. And
you're up in the attic.
Yep. Now we turned my our gaming room into an home office.
But still,
yep, you have to do something, right?
Yes. Well,
1 more minute, right?
One more minute. Otherwise, it's a bad omen. Yeah. Now it's probably okay, but it's 2021.
It is.
Let's get started. Cees-Jan, yeah, you're probably gonna introduce yourself. So
I have a slide for that. So.
All right. I will have all the questions at the end, so you can continue.
Yeah, I put my speaker notes specifically over the chat, so I don't get distracted by it.
Okay, awesome.
Cool.
Take it away.
So, welcome to an introduction, a crash course into asynchronous and non-blocking PHP. My name is Cees-Jan Kiewiet. You can find me on Twitter and GitHub. I do a lot of stuff with asynchronous PHP, but also with some side projects. So reach out after this talk if you have any questions, or if you couldn't think one up during the Q&A afterwards. I'm happy to answer any of those. Let's get started with a definition. So asynchronous is essentially anything that doesn't yield a direct result, which can be drinking water from a mug, because to raise, you have to drink it. It takes a bit. And we're non-blocking. You expect a direct result. And the way we do that, I'll get back to it later, is through smart scheduling. They're both closely related, but they have massive different implications into how your system works, how it runs, and what you can expect from both paradigms. So let's start with a few patterns that are close to home for asynchronous. Most of them, or all of them, boil down to starting operation or deferring it to a later moment. It can be a message queue, where you pop up a message in the queue, you hope it will be finished soon, but if it takes an hour more, then okay, that also works. Cron jobs are kind of that. You mostly use them to clean up things, or do only things that you should do once in a while. It's not per se what you think of classical async, but it's still, in a sense, a deferred operation. Non-blocking applications fall within asynchronous patterns, but so do message-based microservices, which also match with message queues. Something close to home would be multi-curl calls, where you call a bunch of requests in one big call. Something you might have used in the past. And once again, linking with message queue as background workers. Regardless if you talk to them with a queue or directly over a ZM queue or TCP/IP or QTP or whatever. Throughout this talk, we're going to look at an example. In this case, it's a local big bank. Whether you hate them or you love them, or they're just a necessity, everyone deals with the bank one way or the other. And we have a few use cases in there. One of them is transactions. Because without transactions, these days, a bank has nothing to do. And we're going to look at how a bank could be built up. It's not per se the way you would build a bank, but this is how you could build a bank. Secondly is reports. Knowing what goes through your system is the bare minimum you should do to understand what's going on, how it's used, if the business is running well or not. So you need that. And archiving. This is where cron jobs will come in. And this is where we put up scheduled mundane tasks. To start with the transactions. Let's say we have a bunch of services. For example, this service handles any incoming transactions. And we want to know that, or if a transaction coming in is actually useful for us or not. If it has nothing to do with the bank, this is the first location where we filter it out. Because we don't want to put it into the rest of the system. We might pop it off to a different system to look at it, understand why it's happening, what it's happening, but it's not our core example. Secondly, we have our core service. This is where our current state is held. So our clients communicate with it, our users communicate with anyone in the office, ATMs, everything. Because this holds the current state of what's in your bank account, how much money the bank has, what's if you have a safety deposit box or whatever. Then we have outgoing transactions. Now, this one is only triggered if you transfer money to another bank account on another bank, which is both the first and last are the least interesting. So we're going to have a look at the middle one. Meet Bob. It's Monday morning. Bob gets into the office. And Bob wants to know what happened during the weekend. So Bob fires up a request to report. Now, Bob is not the only one. Remember, this is the local franchise of a big bank. So there might be 1,000 Bobs coming in on Monday morning at the same time, opening a laptop and asking for the same report, but for the local franchise. So what happens? Bob asks one way or other to the core server, you know what, can you tell me how much money went in or out of my client's accounts during the weekend? And he doesn't want to have like a detailed list. He wants to have an overview of what happened, if there's anything weird that happened or not. So Bob asks to the core service, and the core service goes, sure, I'll put it in a queue. Because remember, there are thousands of Bobs asking this at the same time. And they want to make sure that that service always stays up. So Bob gets coffee or water. And in the meantime, there's a background job that picks up the tasks. And this task is going to take, let's say, 5 minutes. So plenty of time for Bob to get his coffee, get back to his desk, and hopefully it will be ready. But Bob knows that might be a bit sooner, might be a bit later. It's Monday, so let's relax. In the meantime, that service has got all the numbers. And included in his report, Bob wants to know what the currency exchange is for specific types of currency. So in order to do that, the background worker is talking to an external service that has the information. And this can all be optimized, it can all be cached. But for the sake of this example, let's assume it doesn't. And we want it for the euro, the yen, the pound, and the dollar, or whatever. And we use this currency.net website to do that. So in the example, we first we get the euro. It takes 5 seconds. Get the yen, it's another 5 seconds. Same for the pound, same for the dollar. And after 20 seconds of just getting those exchange rates, we have the information we have, which is, I mean, it's not bad. Bob is getting his coffee, but could be better, right? So once that's done, the worker sends the email, and Bob has its report. You have a happy Bob, because none of his clients lost money this weekend. That's good. Now, this isn't perfect, but it works, right? So let's not care for the moment. Let's have a look at archiving. Because we really don't want to have the information from 1970 still in the system. It's old, and we might need it for an investigation later on, but let's archive it. Let's put it somewhere else. And the way we do that is we have a cron job. It runs every decade or every year, I don't really care. And it gets the data from older than 20 years and puts it in the cloud through a cron job that will start getting the data and start uploading it. Now, this uploading might take a while, but we really want to make sure that the data has been uploaded. So once it's uploaded, we download it again. We check if the information is still exactly the same, because we really don't want to lose data. And once it's done, remove the old data from a system into the garbage can, because we have a verified backup on the cloud, so we can remove it. We can save up and get the new data, which makes us happy, because more storage space, less slow database, and no one was really requesting it anyway. So now let's have a look at some non-blocking magic. First of all, non-blocking, as everyone sees it, essentially is a lie, because it will always block. However, it will only block very shortly. This is due to the way it's done. We use scheduling. So in order to understand that, we have at the very core of the event loop, within React PHP, but also in other projects, are either extensions that hook into the kernel polling mechanism, or they use a built-in function called stream select in PHP. It's been there since PHP 4 something, so maybe theoretically this could have been done for the last 15 years or something in PHP, but okay. So one of the extensions is XUV. It's the same extension as same libraries being used in Nginx as in Node.js and a whole bunch of other projects. It's really, really fast at this. It's also really good. And this is the foundation of the event loop. This does nothing more than talk to the kernel. And the kernel lets us know, you know what, I have nothing for you, but I'll notify you, so have a drink. And it might take a few hundred milliseconds, but at some point, when we have an open connection with something, the kernel goes, you know what, I have data for you. And at that point, we get that notification. And we tell the listener that's in the next tier that, you know what, this stream you want to write to, it's ready to be written to. So at that moment, we write to it. And that means that the function itself, the call itself, is extremely fast. We just put the data we have and pass it on to the kernel. The moment is ready for that. It's the same way with reading data from a stream. We're not going to read anything from it until the kernel tells you know what, I have data for you. Because if we wouldn't, we would have been blocking that call. So in that sense, non-blocking, it's still a function call. So the function call itself still blocks. But because we have data ready at the other end of that function call, it is so fast that you don't notice that it's blocking. and that's fine. That's how all of this works and glues together, and it's makes it extremely fast. Aside from streams, we also have OS signal handling and timers in there. Um, Timers might differ. For the stream selection loop, we had to implement that ourselves. For XUV and other event loops, they come with signal and timer handling, but the effect is the same. So on top of that, we add deferred functions and timers depending on the implementation. And since the event loop actually just keeps coming around, when you first start it will check if any deferred functions are ready. And then it will hook into the underlying kernel polling going on. I have these streams. Let me know if something's ready. And we also give it a timeout. And the timeout is essentially, we know when the next timer is supposed to be executed. So the timeout on the event loop call or run call essentially is wait for incoming IO until this amount of time has passed, because then we have to run a function, have to run a timer function. And that might mean that the timeout might be a couple of seconds, or it is 10 milliseconds, depending on when the next timer has to be executed. And that also works really well. Internally, event loop is tends to do something similar, but it all boils down to a really boring true loop. And the true is going to be true as long as the event loop is something to do. The moment it has nothing more to do, it will stop running. And it's designed that way so that you don't end up accidentally with a never-ending loop run. So coming back to the currency, exchange rate conversion example. This does exactly the same thing. I could have used curl multicall for this, but this is how you would do it in React PHP. You get exactly the same result from it. The block/await all function is a second-party library that will let you wait until a prompt resolves, and it will then return the result. Depending on your application, this is not something we would advise. However, if this is literally just what you're doing with React PHP or another non-blocking tool, and this is fine. If you build your whole application to be running in an event loop, don't do this, because the moment the prompt resolves, the loop will be stopped. And anything else running in that loop will also be stopped. And that might cause you problems down the line. So what happens when you execute this? Essentially this. So all four are getting requested at the same time. And instead of 20 seconds, it takes 5. Because all of them, while they still take 5 seconds each, they're all executed at the same time. So you end up with 25% of your original runtime. Now, this might not be interesting for the big bang or for the end user. But as an engineer itself, being able to cut 75% of that execution time is a great win. And especially if you have 1,000 bobs a day, doing that, you're looking at massive amount of time win that eventually will pay you off in less hosting costs. Now, let's have a look at archiving, because archiving itself, unless you're also doing multiple uploads at the same time, do not change it. Do not make the upload and delete call both non-blocking and at the same time, because you don't want to accidentally delete your data first before you verify that you uploaded it. No one wants to lose data. Not me, not you, especially not your boss, since you could fix it then. So this is one of the points where I wouldn't suggest using that. Because you still want to have your data integrated. So let's have a look at the services again. Because classically with PHP, you'd run Apache or Nginx with FVM behind it. And, well, let's take this service. And you have a bunch. You have at the top, you have the web server. And at the bottom, you have 5 workers. Now, this works fine. You can tune this to be extremely fast. The fastest timing I've seen today was like about 5 milliseconds for a setup like this. But given it didn't interact with the database, I did some computation and returned results. And that's great. That means it's super fast, and this is well work. This works good. But if you have to start interacting with databases, and those queries take a couple of 100 milliseconds each, which is not ideal, but it might happen. Then having 5 workers doing only 1 request each is a bit wasteful. Now, this is where something like React PHP would shine, because you run a single instance of PHP that has everything in it. So it has your basic web server, and that just returns a response. But you can also fill this function with database call, with the same database call, sorry. And they still take a couple of 100 milliseconds each, right? But because there are no limitations on this, you can have hundreds of requests open at the same time at a lot less overhead. Because instead of having 5 workers, you have 1 worker, but it will use a lot more memory. It also can handle a lot of more requests with the same amount of resources. Because part of the time we'll just be waiting. So let's say it's 300 milliseconds and you have, let's say 10 of them coming in at the same time. That means your waiting time purely for those queries will be 3 seconds. And in those 3 seconds, while the request itself is waiting, you can this whole thing have to other things. So I did some benchmarking on this, and just calling that function you saw earlier. So the one here in the middle that gets the server request interface and sends response back takes this bit of a second to be executed. So theoretically, this is all the time you need to create a response. You would still have to handle the request itself, but that example is this fast. However, this doesn't take the I/O into account, which is a whole different matter. So once again, that's just this function. And if you would see how many responses you could get a second with this, that's almost 200,000. Once again, no I/O included. That's also how fast PHP is. This is, by the way, PHP 7.4. I haven't benchmarked this on 8 because not everything is ready for it yet. But React PHP itself is. Some of the other packages I use for testing and code quality isn't fully there yet. So I haven't made the big jump for all my packages to go to 8. Hopefully it's done soon, but I'm really anxious for that, because especially with the new JIT, this might even increase more, but we'll see. So 2,000 of those per 200,000 per second without I/O on the same machine, running the same benchmark, boils down to about 2,500 requests a second. This was a bit of an older machine, so it's not that fast. We're running, one of the other React PHP developers did some similar benchmarks that came up to, I think, 8,000 or 12,000 requests a second with the same code. So depending on how much resources you throw at it and how fast your CPU and memory is, you can handle a whole ton of requests a second. But once again, you're still stuck with how much CPU memory you have to handle that. And CPUs these days have more than one core, which is awesome. However, React PHP by nature is, and PHP by nature for 99% of deployments is single threaded. I'll get back to that later. First, we can do something else cool. So you can run multiple instances of the same application in React PHP and use this socket flag called so reuse port. Now, what this lets you do is instead of spawning one process, you say, well, let's say we spawn 3 or 5 or whatever. And we change this example with just this. And what this tells it to do is that we're going to still listen on port 8080, but so can other processes. So whoever gets accepts the connection first, that process will handle it. So that's a bit of a magic automatic load balancing within your CPU. And it's literally just this bit. Now, we don't enable this by default because we really don't accidentally want people to hook onto the same port as another service might also be listening on. Because this jumps into system administration really, really fast. So this is something to keep an eye on. Another thing is, and this is one of the things I spent a lot of time in 2020 on, and given how 2020 went, this is one of the better things in 2020. I spent a lot of time, you might know pthreads, so by the same author is made X parallel, and it brings threading into PHP. Which might you think, wait, you just said that, yeah, I know. So PHP has two distributions, aside from the whole Windows, Linux, different architectures. It has the NTS and then ZTS. So the NTS is the non-thread safe version, which is what 99% of the PHP developers use. And ZTS is the Xen thread safe version of that. There is a small performance penalty for using that. However, I found that it's worth it. And I started playing with this 2019. I have this World of Warcraft map website that also lets you generate, this was really cool to build, by the way, but to create a static image based on the map showed in your screen. So that means if you want to do that, you have to fetch different tiles that they made of the map, stitch them together. Now, if you've worked with image alteration in the past in PHP or in general, that stuff is resource intensive. So I was running this on a single core or a single CPU VPS somewhere. And I was running it to React PHP, and it was just rendering the images fine. Now, the main problem is that this whole thing is behind CloudFront, so behind the CDN. And when a request comes in, CloudFront will wait until the whole request is handled and finished. That means that if a user is dragging along the map and having the window open to get the static map, you get a whole bunch of requests. Now, a couple is fine, but if you suddenly get like 1,500 requests in like 2 minutes, then the queue to build that is slowly building up. Now, React PHP does a fantastic job in queuing that. Xparallel does a fantastic job in creating that image in a thread, while React PHP still keeps running fine in the main thread. What wasn't fine was the amount of CPU I had. because the whole thing, the whole queue went up, because it just couldn't keep up. And at some point, there was a drop off where it just started going down again, because at that point the user stopped because the screen wouldn't update, and it just gave up. Which for me proved that this works, and it works really well. But it didn't scale as good as I was hoping. So what I did for that is to fix that. It's a bit of a side straight, sorry, but I used Bref, which is a serverless PHP implementation. And that worked really well to run these kind of things. So instead of having one server that handles all requests, it just spawns and scales as needed. So if you're looking at something like that, have a look at Bref as well, but it's really cool stuff. But that whole thing proved to me that this works, and it works well. Because at some point, I think the biggest spike I had was like 5,000 requests in queue. And those connections were still open at that point. So CloudFront maintained that connection with React PHP, and it took, I think, 15 minutes before the whole queue was processed. Now, that means that React PHP A holds open 5,000 connections. CloudFront doesn't give up, and the CPU is just churning to get the images out. And that's the kind of stability I'm looking for in products, that if I toss something at them, they'll process it one way or the other. This, of course, is not the perfect way, but it makes Xparallel really stable. However, if we would run the same example as before, there is a performance penalty there. Now, this mainly is because we have to send requests from the main thread into one of the worker or children threads. And what is really important to keep in mind with this is that if you can do something fast, if it takes like a tenth of a millisecond to do it, don't put it in a thread. Just do it in the main thread and let it handle there. But if you're running a whole PSR15 middleware stack with all kind of hooks on content type, request validation, that might take a bit long. So that's one of the things you want to run in the thread. So that's what I did here, and that's the cost you're getting for doing that. So you have to get the request object, make sure you have no internal classes or no resources whatsoever, because that's the main thing that that Parallel does different than pthreads. It adds very aggressive safety measures. One of the main reasons that pthreads is unstable or doesn't work is because it doesn't safeguard at this extreme. And the reason to do this is to ensure that there are no seg faults, there are no weird errors. We need to try to pass an object or no unexpected behavior, because we're still dealing with threads. And that's still not as simple as you might think. So Parallel makes that super simple. And I wrote some libraries around that. And let me show you how we could use the same example we had before and add that. So first of all, we want to add a worker pool. So we want to have a bunch of threads that we can use to handle requests in. The low level one we're setting up doesn't care. If you want a thread, you'll get a thread. It's fast enough to spawn 300 plus threads a second. I really hope you don't need it at that point, but it is possible. And secondly, we'll make sure that we pass that pool into the request handler. And then we wrap the whole response creation into a callable. That gives you this. Now there is one more change I made, and that's this one once again boils down to the limitations of Parallel. You must return. You cannot use resources, and by default, for a lot of PHP PSR7 implementations, if instead of a string stream you just give it a string, it will use an fopen and put it in a special memory resource that you can use in PHP to store string data in. That lets you seek and rewind and stream over them, which is really cool and useful in some situations, but it's not something we can support here. So we have to wrap it in the string stream. Going back to the full example, these are all the changes you need to do that. This will, of course, take care of any serialization that you need to pass from the main thread to the worker thread. But this is literally it. This is the most simple example I can give you on how to use threads in PHP and handles requests. The only way you could make it simpler is create a special HTTP server running it there. But this gives you the most overview of how that would work. And this works really well. This I got it running in production on a couple of other projects as well now, including my own website at this point that will automatically approve and merge any dependable pull requests. Because I really don't want to come in the morning and go, so sweet. Sebastian from PHP Unit did a new release. And now I have 100 pull requests to approve. I don't want to do that. I really don't want to sit there and go, approve, merge, approve, merge. You can just automate that. And what I did for that is I hooked into the GitHub webhook events. So Git will call the webhook I have somewhere. Gives me the information. I'll have a look at it, and if it makes sense, I verify it through the API and approve the pull requests. And then I get another webhook because I really want to make sure that this works well and that it matches all conditions. That if I approve it and the pull request is in a clean state, it will automatically merge it. And that runs on essentially basically this code. Because that lets me put a lot of blocking calls to verify signatures from GitHub requests inside a thread that doesn't block the main thread. Because sometimes, especially if you hook into events like the, which one is it? Essentially your check suite on GitHub Actions that will tell you for every single job that it's done. And I split up all my jobs into one for PHP unit, one for your code style, one for infection. Infection is awesome. One for Psalm, one for PHP stun. I think one or two others. So sometimes it just gets 10 requests at the same time, but this handles that just fine. This means that I use some CPU in a thread to verify signatures, but I'm not blocking the main thread to handle and accept more requests. Just so that's really cool stuff, and if you want to help with that, let me know. There's it's talking about non-blocking and React PHP itself is not a big group, and going even with threads and things like this is even smaller. So that's it talk-wise. Thank you for listening to me. If you have any questions that you think I don't want to ask, just really please ask. No matter how stupid you think it is not stupid. And also feel free to reach out on Twitter or on email, or you know where to find me. Or otherwise, Michelangelo does.
Well, Cees-Jan, I'm speechless. Great session.
Thank you.
When you mentioned you get little or no question, is because you actually explain it very, very well. So, so thank you very much. We do have a couple of questions.
Cool.
Well, the first one is a remark in regards to the Philippine peso uses PHP as code. So it was a suggestion to put it in your currency listing.
Yeah, I know this, and I also have some PHP currency here. So the whole PHP of net is kind of a hidden joke for that. So yeah, thank you for picking that up.
Okay, next one.
Yes.
This one is by me. Is it possible to add retry patterns in the async request? Because sometimes you have a service that is either not responsive or not responding within a certain amount of time.
Yeah, it's essentially the only difference you have with it. Your normal PHP, the way you're used to it, is that the whole I/O is asynchronous. So you can do retries, you can follow redirects, and all of that is possible. But still, it's a matter of putting it in there and handling it the way you expect it to.
Okay, well, thank you. As long our long-running PHP process is not a problem anymore these days, memory leaks and such. Stephan, I think he speaks out of experience.
So yes and no. You're still a developer. You still have to take care of your own memory leaks. But since you're hopefully have monitoring on that, I know I do. Is that at the moment your memory keeps going up and up and up, you should know and notice that something is wrong. We spent a lot of time for React PHP itself, at least, to optimize for no memory leaks. This is and will always be somewhat of an issue, I guess, especially when you're not paying attention to it. But I have projects that would run, and I know this is bad in a sense, but they would run for months without issues and without updates, which is the bad part. But so yeah, it's not as in the old PHP 5 days, especially. I mean, who here worked with PHP 5.2 and below? Because yeah, it's actually me as well. So for those who hasn't, one of the big cool things in PHP 5.3, except for namespaces and a whole lot of other stuff, is it had an improved garbage collector. And that essentially means that it got a lot better in cleaning up your mess. Yes, me too. I think I started in 4.1 or something. But that means, and I worked at a company at some point that was running a few different PHP versions. And 5.2 was one of them. And that was one of the projects where we had a memory leak in one of the imports. And my first reaction was, wait, this runs 5.2. Can we please update it to 5.3? Because that would improve this a lot. No, we can't. Find a way around it. So 5.2 had, up until 5.2, the whole memory, the garbage collection did, but essentially what this question stems from, I guess. It wasn't very good at garbage collecting, which I think makes sense for what most of the developers do back then, is handle requests, maybe run a small scripts, but do not get a CD delivered by courier. You put it in a local machine, and then you run a script on it on, like, I think it was 650 megabytes of XML, parse that, and put it in a database. It was not designed to do that. And you have to take it into account, like anything you write. Like what Stephan now says in the chat, that's also yes and no. You have to be careful what you pull in as libraries, but it's not a requirement to. It's not a requirement to have fewer libraries to run well. It's a requirement for those libraries to essentially be isolated, containerized on what they do essentially. So if it's let's just say returns a string or whatever from your input, it shouldn't leak anything out from that function. The moment that function or class has been used, is done. There shouldn't be any references to anything else in your process. And can you pop up the next question, because that one, yeah.
Yeah, I was doing this. It's this one.
Yes. Yeah. So it is the yeah. Well, it is a question, right? So the quality of the libraries matters a lot. I'm not going to bash any framework here, but if you have, let's say, a Cake or a Symfony or a Laravel library yeah, that hooks into anything aside from that, you have potential for a memory leak. And this is something that this is why I always run the full application also locally. So I can both test it locally, but also see if something is starting blowing up or not. Because if you go for lunch locally, really PHP says 6, if you run it locally and it blows up in memory over lunch, something is up. So that's really important to be aware that everything works fine. And I spent a lot of time picking libraries when I need something that just does the thing it's supposed to do. That doesn't hook into an external. I don't care about sub-dependencies that much, but I do care enough about them that they should all match the same expectation. They should all just do the thing they're advertised and not hook into any other connections or singletons or globals, because that has potential for a mess.
Yeah, how do you since we're on the subject, how do you decide which library will you pick and which library you want?
I would always prefer a recently updated library. And for some reason, also always like to play in the underdog. So when I look for a library that does a specific thing, for example, setting a cookie on a piece as a request, I just wanted to do that. And if there's a package that does just that, that has a couple of thousand downloads and it has been updated, 2019, but it would still work, and sure. But if there's also a package that does that and a couple of other things, but has the potential to be, how to say that, to cause trouble down the line, even though it has 100,000 downloads, I would still pick the smaller one. And that's
because of its laser focus.
Yeah. And like I say, I always also like to use something that might not be used a lot, as long as it's small and contained. Because it's always fun as a developer to see people using your project.
Yeah. Well, I think that we're through all the questions. Cees-Jan, I thank you very much for appearing here. It was a great session.
Thank you.
Probably I speak for a whole bunch of people, but yeah, you nailed it. Thank you very much.
Thank you.
Okay, I will make you attendee again, and I will have to make you, where are you? There you go. Make attendee. Bang. Okay. Now that I have kicked out Cees-Jan into the session, oh, this is the wrong. I need to have this. Normally we have join in as a CI system for our speakers. I made the request last year actually. It's still not being accepted, so I'm not really sure if join in is going to fulfill my wishes. Hopefully they will, and hopefully it will be ready for next time. But in the meantime, we're actually going with good news. It's January. We have to bring good news. Everyone here is a winner. So if you registered through Meetup, I will look up your names from the chat, from the attendee list here, and we will send you the information about the discount again, if you really want to participate in this online PHP conference. Just go to the PHP CC and look at the schedule. You really, really want to be there. But wait, I also mentioned at the beginning, they are sponsoring. There's a ticket that we can give away. So that means that one of you will get a 100% discount. So don't go off and book now. Wait until after the raffle, okay? So it's raffle time. Let me double check if I have all the names. Ooh, I'm missing one. Not good, not good. Okay, let me see if I can get this. I need to share my screen. So I can not really see if everyone is seeing it, but I expect it is. It's the wheel of names. So I put everyone's name in this list. And I think it's time to start the raffle. I'm getting all kinds of messages. Yes. So let's go back to the presentation, and we're going for 2 elephants presented by Mark Baker. By the way, Mark is in the audience, so please give him a round of applause, please. And it's time for me to click and spin. So Marcel Toll, you have been a lucky winner of an elephant provided by Mark Baker. So we go for the second elephant. Ivo Peders, congratulations. And now we're going back to, again, elephants, this time sponsored by Heroku. By the way, is there anyone in the public who doesn't want to have elephants? Nah, just kidding. So Robert Brun, you will get a Heroku package. And the second package goes to Jerome Gomez. Congratulations, both. Next prize. The free ticket for the online PHP conference. It will be next month. So next week, I'm sorry. It's January 18 to 22. This is a ticket for the conference. And it goes to, very exciting, Ivo de Klerk. I hope Ivo can make it to the conference. I'm seeing him typing now. Yes. This is a conference you really want to make time for. So yeah, congratulations. All right, awesome. Oh, I wasn't here you can see, by the way. Next up, these are again 3 tickets for Frontline PHP, the full tutorial. This is the price worth. So let me share my screen this time. Win. Congratulations. No, we had 3. I'm sorry. So Wim is 1. Mark Baker, you're number 2. Congratulations. Ooh, your Dutch is going very well, Mark. Well done. And number 3. Sander Krul. Congratulations. And Spassy wouldn't be Spassy if they didn't produce anything else. So last week they announced the release of Ray, which is a dumb debugger project that they create, and it's super fast, super easy to use, and it comes with a installer for your operating system. So no need to go through all kinds of logs and all kinds of weird inspections you need to do inside your applications. This is an application that inspects from the outside in. And everyone who's using Ray is very excited about it. Unfortunately, I don't see Freek in our session here. Otherwise, he could give a small introduction about Ray. But he was on the YouTube live stream. So, Freek, thank you. And he told me we have 5 tickets for free usage of Ray to give away. So Chris. Congratulations. I see also the question, does it run on Linux? Yes, it does. And I'm not sharing my screen again. Ralph Junghans, you're number 2. Ray, number 3. Dieter, congratulations. Arjan, you're number... Am I number 4 or 5? 4, okay. Congratulations. Number 5, okay. So this means the end. Everyone who won a prize, please send an email to meetup at phpbenelux.eu. So we have your contact details, and we need your shipping address for the physical goods, or the email address and your name, so we can provide it to the PHPCC to create your ticket, or to Freek to give you the coupon codes. Dan, this is really touching my heart. All right, let me go over the presentation. We had the raffle, and so all that's left is for me to say thank you very much for attending. It was a great pleasure having you here. We have a meetup every second Thursday of the month. So February 11 will be our next meetup. And Cees-Jan mentioned GitHooks in his talk. And by coincidence, we have a talk already lined up about GitHooks. So you definitely want to join us next month for this presentation. And the other one, we will let you know as time goes by. So thank you very much. Stay curious, and don't forget, community works. Bye, everyone.